Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. So far, we have looked at native resources, how to manage them using auto-closable, and we looked at the file streams, and we said that files, in order to read a file or write to a file, we have to talk to the operating system, and through the operating system, we talk to the hardware. And now we can also look at how to work with a standard I/O, a standard input/output, and this is typically the use case is when we have a console-based application. So the user is going to interact with the console and write something in the console as the input, or the application is going to print something to the console as the output. So this is called the standard I/O. So sometimes is also considered as the console I/O, right? And we already know how to deal with it in C++. It's an extremely easy library in C++. We include the I/O stream, and then std in, std out. These are objects streams or character streams that take the characters from the console, and then they can put them in any object, any primitive types in the standard library, like int, float, double. And in Java, we know that Java has system.in and system.out. In is the standard basically I/O, and these system.in is pretty much equivalent to std_in, and system.out is equivalent to std_out, right? So this in system.in, in is basically a static object inside this system class that is basically handling all the console input, and this is the stream. If we want to use this in, we have to use a class like a scanner and direct the stream from the system.in to the scanner, so we can read the floats, double, all the user inputs. Similarly for system.out, we can have something that, and system.out, I believe it's a print writer or print stream, which means it just provides a print line, print f, or this kind of functions or methods. But then again, because now we are mastering JNI, we understand how the JDK designers actually wrote the Java code that does this kind of console streams. And again, we need native calls because again, the console is managed by the operating system, right? So we have to talk to the OS. This means we have to do native calls. And it turns out it's extremely easy to implement our own version of a standard I/O using JNI. So let's say I want to write a class that handles all the console inputs. I call it console in. And we can do also a similar class, console out, that handles all the user outputs, or all the outputs that the application makes to the console. Note that here we are dealing with the console, right? Not the a file stream. This is just the console. And then we typically do this or implement these in and outs as a singleton design pattern, because we know that when a Java application runs, it runs on a JVM. So one instance of the JVM is loaded into the memory, and then it loads the actual Java application. So we want to have only one object for handling the inputs from the console, and one object for handling the outputs to the console, right? Because there is one console per Java application, per JVM, and this is pretty much the singleton design pattern. So only one instance of the standard I/O per JVM, and that's why these in and out objects in system are also static, right? Because we cannot instantiate them, but they're there. There's only one instance of the input and one instance of the output. And the good thing about these standard I/Os, for example std_in and std_out, these are the native console I/Os, is that we don't really need to open and close them, because when we run the application, it is assumed that these are already open. We can use them because the application is supposed to interact with the console anyways, right? So we don't need to manually open these standard I/Os or manually close them, because the underlying native streams std_in and std_out, we don't need to open and close them. Right? So unlike files, for file streams we have to manually open and close them because we're talking to the hardware, but here we're not really talking to the hardware, we're talking to the console, and console is part of the OS. So we are talking to the operating system, not the actual hardware. So the operating system doesn't need to actually talk to the hardware when we're talking to the console. So I have this public class console in, and again we need a static initializer to load our native library so that the very first time we instantiate or use this class, the dynamic library is loaded into the memory, and we can use this native console stream cin and cout. And I have this again private static native init IDs, and I call it, but here we don't really need any fields in this console in class, so we don't really need to have any fields, and this function init IDs is supposed to be empty. However, if we really want to buffer a few things that the user puts in, then we can have a buffer here, an array of strings or whatever types that we want. And then as I mentioned, we typically want to use these classes that handle the console in and out as singleton, so the constructor should be private in theory, and then we have a static final field that is one instance of this console. For now, I just assume that I can instantiate it, and then we can later change it to a singleton design pattern. So what do we need from console? We have to be able to read any type of data that the user inputs to the console. So it could be a string, so we can have a next method that reads the next word, next int that reads the next integer that the user puts in, next double, next float, next byte, next short, next character, etc. And I assume you are very familiar with this type of methods because these are the standard method inside the scanner class. So the good thing here is that when we write our own console in, we can actually provide methods that return an actual object. Let's say an object takes a name and an age, so a string name and integer age, and then it constructs an object, let's say a person object. So we can natively create in the C++ code, we can read two values, a string and an int, and use a JNI to create a Java object in C++ and return it directly to Java. On the other hand, we can also read the two next words and then parse them into an object in Java. So it's up to us on how to actually deal with this. So obviously we have to check if we want to return an object directly. We have to check that the type of information that goes in the constructor of that object is correct. So we have to do some checking, and it's easier to do that kind of checks in Java, so we can throw exceptions if the type of information is not correct. But for now, let's just assume we have a next int, next float, next double. All right. So again, it's very easy. So let's head to Eclipse. I'm going to create a new package in our Java project called test24. Test24, and I'm going to create a new class called console in. All right. And I don't need to open or close any resource, so I don't really need to implement auto closable. So what I need a static initializer, and I need to be sure to load the dynamic library the very first time this object is loaded into the memory. So the name of the dynamic library is native C, and then we can have that init IDs, so private static native void init IDs. This is a standard approach, but in this case most likely we're not going to have any fields, so we don't really need to initialize any field IDs in C++, but we can keep it because it's a standard template and it's always good to have it there. All right. So what do I need? Let's make the constructor public for now so that we can instantiate it, and then methods for reading user inputs to the console. So what kind of methods? Let's say we want to read a word, a string, right? So then public native, this is a native call, a string next, and then an integer, public native int, next int, and then let's say double or float. Let's start with the float, public native float, next float, and double, for example, public native double next double. All right, That's it. That's all we need. So this is the entire class, and then all we need to do, we need to provide native implementation or C++ implementation of these native methods. So what I'm going to do, I'm going to the C++ perspective, select my Java code and run the Java H tool, and it creates the header file and puts it in the header folder of my C++ project. It's called test24, and we have an init IDs, next int, next float, and next double. All right, and then I'm going to the source folder here, src, and create a C++ folder called, I'm going to create a C++ source file called, let's say, console.in.cpp. So the very first thing that we do, as always, we include that header file, test24, and then we copy and paste the prototype of the functions to our CPP file so that we can provide implementation. All right, so the first parameter, JNI environment pointer, I call it JVM, and then I copy and paste it to also to the other functions. And for the init IDs, it's a static method, so the J class is the calling class. I call it console.in_class, and this function for now is going to be empty. We're not going to initialize any field ID. And then JObject is, again, it's an instance method. So JObject refers to the instance of this console.in, the object that we instantiate, and then I say obj. And then so let's also copy and paste this object to other functions. Okay, now we have to provide implementation, and again, init IDs doesn't need any implementation at the moment. For the next, we're going to return a J string. So we're going to return a word, a string, and then send it to Java. So I'm going to include IO stream, because we're going to work with the native streams, native console streams, and then include a string, although it's not really necessary. I'm not going to use any functions in the string, but I'm going to include it. So here we're going to just define a std string on the stack. Let's call this next, and then std cin, extract and put it into next. And again, this operator, greater than is overloaded for all the primitive types in C++ and also the std string. The good news is that all the primitive types of Java directly map to all the primitive types of C++. So, and because this operator is overloaded, it's extremely easy to read a Java type and then directly to cin, from cin, and then send it to Java. So again, this operator, greater than, or is called also extraction operator, I believe, is overloaded for std string. So it reads the next string from the console and puts it into this std string, and then we ask JVM to create a new Java string, new string UTF, and we cannot pass a std string here, so we have to convert this to the C string, so CSTR. All right, so this creates a const char pointer. Value type is a character, so it's a const char pointer, which is what the new string UTF expects. Now for the primitive types, it's much simpler. So next int, I just define a jint next, and then say std cin, put it into next, and return next. And the reason is that the primitive types of the JNI, like jint,jdouble, they directly map to the C++ types, primitive types, and this operator, the extraction, is overloaded by default for all the primitive types of C++. So it's extremely simple to do this and then send it directly to Java. So next float, and again jfloat next, and then std cin, extract the float and put it into next, and then return next. And I'm directly returning this next, which is a jfloat, and jfloat on my machine is just float. All right, what about double? The same story. So jdouble next, and then std cin, extract it, put it into next, and directly return next. So the only difficulty is with the string, because the C++ string is different from Java string. So we have to manually create a Java string and send it to Java. For primitive types, it's extremely simple. We just read it just the way we normally read a primitive in C++ and send it to Java. So that's it. That's all we needed to do. As you can see, working with a standard console input is extremely easy. So all I have to do, I have to build this. The build is fine, and then copy and paste the dynamic library to my Java. And now I go back to my test24 package. Let's create a test class. So test console in, and let's have a main method. And what I'm going to do is I create a method called test1. And in the test1, I'm going to say, so public static void test1. And in the test1, I'm going to do a sysout, let's say, enter your name. And then I'm going to say this is print. All right, so it doesn't go to the next line. So enter your name, and the user now is supposed to provide an input, right? So we can instantiate our console in, new console in, and then I say a string name is in.next to read a string, and then do a sysout your name is let's do printf here, or print line, it's fine. So name. All right, so we created our own version of the console input, and then we are reading some input from the user, which is a string. So let's run this, and hopefully this works fine. So note that I don't need to load the dynamic library in this class, in this test class, because I don't have any native method in this class. I have native methods inside the console in, and I'm already loading the dynamic library. So as soon as this console in gets created, this is the first time it's loaded into the memory. So the dynamic library associated with this object also is loaded into the memory, right? So it says enter your name. I say it's Bob, and says your name is Bob. So it took us about 5 minutes to really implement our own version of console input. Extremely simple, extremely fast. So JNI is very powerful and very quick. We can quickly implement our own console input and output. Now let's test other methods. So I do a sysout enter your age, and then let's do a print instead of print line, and then int age is in dot next int, and then sysout your age is plus age. Enter your name, it's Bob. Enter your name is Bob. Enter your age is 21, and your name is 21. So we are successfully reading a string, reading a double, reading an integer. So what happens if I run this and enter a double instead of integer? So Bob 21.5, your name is 25. So it automatically does typecasting. Okay. So how do we normally do this? We normally do this kind of stuff using a scanner class. So I'm going to also demonstrate it to you. And now that you have already been familiarized with the JNI, and you see how extremely easy to write your own console input class, you can, if you don't like to work with the scanner class, you can write your own, as we just did. So public static void test2. In test2, we do a sysout and say enter your name, but then we create a scanner from Java util. A scanner is new scanner, and then the scanner constructor actually requires a stream, a source of the stream, readable path input stream. So I'm going to say it's an input stream, and for the input stream I'm going to say, or basically direct it to the system.in, which is the console input. All right. So this system.in is an input stream. The standard input stream is equivalent to stdcin, right, in C++. This stream is already open and ready to supply input data. This is basically the same as I mentioned, that we don't really need to open or close stdcin and stdcout. That's why we see that in the documentation of the system.in says that this is the standard input stream. This stream is already open and ready to supply input data. Typically, this stream corresponds to keyboard input or another input source specified by the host, environment, or user. So this is typically the stdcin in C++, and therefore this input stream in Java. These are typically associated with the keyboard, the user input. All right. So we do this scanner, but as you can see, it implements auto closable. So we need to actually close it, the value of the look, and then I guess we need to call the close method eventually. But for now, let's say a string name is a scanner, and it has a next line, next, and then a next, which reads the next string, and then sys out basically your name is this, and then enter your age, and then we say a scanner dot next int, and then we say int age, and we can do a print on the age, right? But now we have this warning, and the warning says that resource leak, a scanner is never closed. So you might be wondering, why do we have this warning when we know that the standard input output, they don't require to be open or closed? And that's the reason is that this scanner class is a general class. It's not directly tied to any particular stream, input stream, right? So it could be a file input stream or a system, a standard input, or a path. That's why it's a general class that implements auto closable. Let's see. So they wrote a simple general purpose class, and it actually implements closable, not auto closable. But these more like closable and auto closable are more or less the same thing. Closable extends auto closable. So so a scanner is a general purpose class, and it does provide some buffering. So it provides about 1 kilobyte of buffer size, character buffer. And you can go into the basically into the source code of the JDK and really now understand what's going on. So right now we're not doing any buffering in our input console because we're assuming that that the JNI calls are not very expensive, which in typically is the case. But if we want to even make it faster, we can provide buffering and then read a lot of characters and then parse them or send them back to Java. So let's see if so let's also manually close this scanner dot close. And again, the reason I'm closing it because this scanner is a general class, and regardless of what kind of input stream we provide to it, that's why it always assumes that there is some sort of native resource that we need to close. So if I run test2, it should more or less give us the same result as test1. So let's run this. Enter your name, Bob. Your name is Bob. Enter your age, 21. Your name is 21. What happens if I enter a double? So Bob, your age is 21.5. It throws an exception, input mismatch exception, right? But in our case, we just send it to Java, and because we read a double, and then in C++ it gets truncated. So it's a double, but when we send it as a JInt, the C++ compiler basically, yeah, we want to read an integer. If we put a if we put a double here, the cin, stdcin automatically truncates it, or the compiler. This reads a double. When it uses this insertion to put it into an int, the compiler automatically does a casting and throws away the decimal part and keeps only the integer part. So in our case, our code didn't fail. It just did the automatic casting, which I guess is fine. We can do basically more checks in C++ or in Java to handle this kind of mismatches if it's really critical. But in our case, in this simple example, it's not really critical. So the other thing here is, as I mentioned, we can actually provide direct implementation of objects. So let's see, I want to create a class called person, and in percent I just want to have a string name and int age, and then in the constructor public person a string name and then int age, and then this dot name is name and this dot age equals age, and I just want to do to a string. So source override generate to a string. All right, so let's have the to a string. So what I want to do, I want to go to my console in and say create also a person, public native double next person. So I want to create a person, read a string, an integer from the console, create a person and send it to basically C++. Now obviously one way to do it is just manually read a string and int, and then this actually should be person type, the return type. So one way is to do something like this, make it a regular method, so next person, and then say a string name is next, and then int age is next int, and then return new person name and age. This is one way. So we are manually reading the string and int and then creating a person in Java and returning it. So let's see how this works. Let's go to our test console. So I'm going to create a new test called test3, public static void test3, and then test3, and here I'm going to say enter name and age. All right, and then we're going to say that person basically, or we create our console first, console in is new console in, and then we say person is in dot next person, and then do a sysout on the person. All right, so let's run test3. So Bob, comma 21, and we see that we were able to successfully create this person, and then call the toString method. Now obviously we can do the same thing natively, so we can implement this method completely natively, and in the C++ we can read a string and then an integer, and then ask JVM to create a person and then send it directly to Java. But I guess this way of just manually reading the name and age and then creating the person in Java, it also works. So this is a better approach. It's an easier approach. But if we really need to create it in C++, we already have seen how to create objects in C++. All right. So this is one thing that the scanner class, for example, doesn't really provide us. A scanner is just for reading basically primitive types or strings, but sometimes you just want to make it easier to read the information of an object, a string, integer, double something, and then directly construct the object. So you want your console in to directly give you the object that you need. Now obviously if we have console in, we can also have console out, which is again I probably look at it in the next tutorial. So the last thing that I want to look at here is we can also transform this into a singleton pattern. So the way this is going to work, let's say create a class called system, and in the system I'm going to have a okay, so maybe let's delete this because we're already using system. Then let's create a new class called my system, and here I'm going to say public static final console in, and then we're going to say that this is new console, or actually we need to say that console dot get instance. This is a standard or console in get instance, and then we go to console and then make the constructor private, and then we create this static method. So public static console in get instance, and then we here basically also create a private static final let's call this console in instance, and then we can make it private or not, but okay, so let's remove this final here, and then we say that if instance equals null, and then basically instance is new console in, and then return instance. All right, so we made this console in into a basically singleton pattern. Right now we can only have one instance of this console, and then in the test console here, now instead of doing this, we say that console in is basically instead of doing in, we say that my system dot in, and then the same thing here, instead of instantiating it, we say that my system dot in. All right, so this should work fine again. Let's start with test one. Enter your name, Bob. Enter your age, 21, and your name is 21. All right, so I hope you enjoyed this lecture and now have a very good understanding on how to work with standard input and outputs. As we saw, the implementation in C++ was extremely easy because the extraction operator from the cin is overloaded for all primitive types and also the std string type, so it was very easy. So please stay tuned, and I'll see you in the next one.